Let's see molecular formula. So the molecular formula shows you the actual number of atoms of each element in the compound. Let's say I have H2O2. This is the molecular formula. The empirical formula is HO. Now, how do you get the molecular formula from the empirical? What I do, I find the MO of the empirical. So MO of empirical, so this is 16 plus 1, so that's 17. I find the MO of the molecular formula, so the actual MO. So this is going to be 34. So actually, you can see that the molecular formula is a multiple of the MO of the empirical formula. So 34 divided by 17, that's 2. So this is why we have H2O2, right? So this number 2 is being multiplied by the subscript that was here. So this was subscript 1, which we don't usually put. So it was 2 times 1, 2, 2 times 1, 2. So H2O2. Let's see how that works. So empirical of a compound is this. It's molar mass. So molar mass means its actual MO is this. So empirical formula is given. So I'm going to find the MO of the empirical formula. So this is 30. Now I have the MO of the molecular formula. This is 90. So then the value of X will be the MO of the molecular formula divided by the MO of the empirical formula. So that's 3. Therefore, the molecular formula is going to be 3 times the empirical formula. So 3, 6, and 3. We're going to multiply the subscript by 3. So here the important thing is finding the value of X. How many multiples of the empirical formula do you need in order to get the molecular formula? Let's see example 2, where you have carbon, hydrogen, and oxygen. So first you need to determine the empirical formula. Then you need to determine the molecular formula. You will always need empirical first before finding the molecular formula. So if you find the empirical formula, this is what you get. And to find the molecular formula, so you use the actual MO. So you need to find MO of empirical formula, which is 31. MO of molecular formula, this is given in the question. This is 62. Therefore, the value of X is 62 divided by 31. So that's 2. Therefore, the molecular formula is going to be 2 times this formula as a subscript. So C2H6O2. See the last question. So you have percentage of carbon, MO of benzene. What is the percentage hydrogen? So we just did that in the previous question. So you can just do a subtraction because benzene contains only carbon and hydrogen. Calculate the ratio of moles of carbon and hydrogen. So carbon, hydrogen, 92.3, 7.7, divide by AO, 12, 1, divide by the smallest. Actually, they are both almost the same. So 1, 1. Therefore, the empirical formula is CH. So mole ratio is 1:1. So that's the mole ratio. And then calculate the empirical formula. Empirical formula is CH molecular formula, you need the MR. So MR of empirical, that's 12 plus 1. MR of molecular formula, that's given 78. Therefore, value of X is 6. Therefore, molecular formula is C6H6. With this, we end mole concept.